In question 4 through 7, we're asked to tell whether the IVT applies to the function over the given interval. And if it does, we're supposed to find the values of c guaranteed by it. So our first function is f of x equals x squared plus x. And the interval that we're looking at is 0 to 2. And the first thing we need to think about when using the intermediate value theorem is to ask whether this function would be continuous from 0 to 2. Now this function is a polynomial function, and polynomial functions are continuous everywhere. There's no holes, gaps, asymptotes, anything like that. So the first condition of the IVT is met. It is continuous on 0 to 2. The next thing that we're going to need to do is test the endpoints and see what their heights are going to be. So I'm going to test f of 0, and then I'm going to test f of 2 to see what the corresponding heights will be. F of 0 ends up being 0 squared plus 0, which of course is just 0. F of 2 would be 2 squared plus 2, which is 6. Now I'm going to graph my results so I can get a visual of the situation. Okay, my first endpoint would be 0, 0. My second endpoint would be 2, 6. And what the question is asking is there a value c that is between 0 and 2 for which f of c will equal 2? So what it's really telling us is that k is equal to 2. So the next thing I need to really concern myself is this value of k between f of a and f of b? Well, f of a is 0. That was our one endpoint. And f of 2 rather, was 6. That's our other endpoint. Does 2 fall between 0 and 6? And the answer is yes. So I'm going to write k equals 2 is between f of a and f of b. So that's the second condition of the IVT, which means the intermediate value theorem is going to apply. The next thing I'm going to do for the visual is I'm going to plot a horizontal line at 2. Now we're going to put it all together. If f is a continuous function, and we said that it is, that means I've got to draw the function from this point to this point without lifting up my pen. And if I do that, does the intermediate value theorem guarantee that I will cross this line y equals 2 at least once? The answer is yes. It's going to cross right here. Now it could cross more than one time depending on what that function looked like, but the intermediate value theorem guarantees at least one crossing if the initial conditions are met. So now we've got to find out where that crossing is. So what I'm going to do is basically intersect these two curves together. The curve that they give us, which is f of x, and the line y equals 2. I'll move the 2 over, setting everything equal to 0, giving me x squared plus x minus 2 is equal to 0. I'll factor x plus 2, x minus 1. I'll set each factor equal to 0, giving me answers of x equals negative 2 and x equals 1. And if we look back to our initial interval that we're supposed to be focusing on, we're supposed to be focusing on only those x's that are between 0 and 2. The only answer that I got that's between 0 and 2 would be positive 1. So according to the definition, they just refer to this as variable c. So to answer the actual question being answered, we will say that c is equal to 1. And once again, we're not going to pick the answer negative 2 because it's not in the initial interval. Okay, so this first sample took a little bit of time, but the other ones, the subsequent ones, are going to be played out the same exact way, and they'll probably move a lot quicker. For question 5, let's again see if the IVT applies, and then we'll find the value of c, if there is any, for which the function will reach a height of 3. So the first thing I need to consider is whether this function is continuous from 0 to 16. Well, if I look at the function f of x equals root x, there aren't any bad x's between 0 and 16. Every one of those values is in the domain of the function. So there aren't any continuity issues between 0 to 16. The next thing that I'm going to do is I'm going to establish the height of the endpoints by first checking out f of 0 and then f of 16. F of 0 is of course 0, and f of 16, the principal square root of 16 is 4. Now I'm going to draw a little graph to illustrate what I've gotten so far. Okay, 0 is sent to 0, 16 is sent to 4. We established that the function is continuous for all x after 0, including 0, which means I'm able to draw the graph from one point to the other without lifting up my pen. So I'll go ahead and do that. And now the k value is actually 3. Find the values of c on the interval from 0 to 16 for which k equals 3. Now, k equals 3 is in between f of 0 and f of 16. Since the initial conditions of the IVT are satisfied, that means the IVT will work and it's going to guarantee at least one c value on the interval from 0 to 16. And to find that c value, I'm essentially going to intersect these two curves. So I'm going to write root x is equal to 3. So I'm going to write root x is equal to 3. Squaring both sides, I get x equals 9. Is 9 in the interval between 0 and 16? The answer is yes. So this is our answer, but I'm just going to rewrite it in terms of c. And there you go. C is equal to 9. Okay, I think you're going to really enjoy question number 6. Once again, it's an intermediate value theorem question. The function they give us is f of x equals 1 over x. In my class, this is the function of the opposing boomerangs graph. And the interval they give us is -3 to 1/2. Well, the first thing that you need to consider when using the IVT is whether the function is continuous on the given interval. And this function, the opposing boomerang graph, actually has an issue at 0. And 0 is in that interval that they're giving us. So for that reason, because condition 1 is not satisfied, we cannot make any guarantees by the intermediate value theorem. So I'm just going to draw a quick illustration to show you what the problem is. Okay, so our graph looks like this. There's going to be a vertical asymptote at 0, and there's going to be a horizontal asymptote at 0, and the graph is going to look like this. Now they want us to look at this graph from -3, so let's say we plug in -3, 1, 2, 3, and they also want us to look at x equals 1/2. So if this is 1, maybe this is a half up here. So they're having us look at this, which I'm making red, and this, which I'm also making red. But remember, the first condition of the intermediate value theorem is that the function has to be continuous on the given interval. And we can see quite clearly there's a discontinuity, there's a vertical asymptote on that interval. So therefore, the IVT does not apply. But we just have to write a little sentence to explain that. Okay, so in this question, we have an example of a function for which the IVT does not apply, and we gave a brief explanation why not. Okay, we're on our last example of our intermediate value questions. Question number 7 gives us a function f of x equals cosine of x on the interval from 0 to pi over 2. So let's first just think about that function for a minute, maybe visualize its graph, and ask ourselves, is that function continuous from 0 to pi over 2? So maybe I'll start with a quick sketch of cosine just to remind you of what it looks like. Okay, so here's our cosine graph right here, and they're asking us to specifically look between 0 and pi over 2. What I'm looking at on this graph is to see whether it's continuous or not. And yeah, I'm not lifting up my pen at all. There are no asymptotes or holes or gaps of any kind. So yes, this is continuous. So f of x is continuous, but I'm going to jump ahead to the next element, which would be to establish f of 0 and f of pi over 2, to establish the heights of the endpoint, which are pretty obvious because I have the graph here. So let's first look at f of 0. F of 0 would be cosine of 0, which is 1. And now we'll look at f of pi over 2, which is cosine of pi over 2, which is 0. Now, the k value that they give us in this problem is -1/2, which on the graph would be down here. And yes, while there are places where the graph is at a height of -1/2, is that going to occur on the given interval? Again, we're only focusing up here. So the second condition of the intermediate value theorem is that your k needs to be in between f of a and f of b. So really what that's asking us to look at is we have a k value of -1/2. Is -1/2 between these two values? And the answer is no. So our conclusion is that the IVT does not apply since k is not in between f of 0 and f of pi over 2. So I provided you a few illustrations and examples of IVT and questions involving the IVT. Just remember the three components of the theorem. There's condition 1, which addresses the continuity of the function on the interval. Condition 2, which has you test where k falls in relation to f of a and f of b, and then the result. If conditions 1 and 2 are met, then the IBT guarantees at least one value of c between a and b.